Hey everyone, how's it going? In this video, we're going to discuss what projectile motion is. So, if I were to draw, let's say, a cannon that's shooting a cannonball, it's going to follow a path that looks something like this, right? It's going to go up into the air and then it's going to come down. So, this is an example of projectile motion. We can define projectile motion as being movement that occurs in a parabolic fashion under the influence of gravity, right? So if you think of this cannonball, if you think of just, throwing a baseball in the air and catching it, those are all examples of projectile motion because the object moves up and then it arcs back down, and all the while it's being influenced by gravity. Okay? So to draw kind of like a rough diagram of what's going on, let's say I have some object right over here, and let's say it's going in this direction. This is the diagram of its velocity. Well, that velocity I can break apart into a couple of components, right? I can say it's going this velocity, this is its velocity in the x direction, and I can say it also has a component in the y direction, we'll call that Vy, right? So what's separating Vx and Vy? Well, it's this angle theta over here. And this is a diagram that's actually going to help us out a lot. Using V and theta, we can define Vx as being V cosine of theta because it's adjacent to that angle. Likewise, we can say Vy, the vertical component of the velocity, is V sine of theta because it's the opposite component. Okay? All right, so when an object is flying through the air and it's undergoing, the influences of gravity and everything, let's talk about the accelerations. When we're discussing the horizontal aspect of the velocity, what acceleration is there? If we disregard, air resistance and friction and all that, there really isn't anything changing the horizontal velocity. So what we can say is that there's no horizontal acceleration. And what does that mean? That means that Vx is constant. So when you throw something in a parabolic fashion, the horizontal component of its velocity is always constant. For example, if we go back to the cannonball example, I can have the cannonball if I took snapshots of it at different points in time. Let's say, it has some velocity going like this. Here, the velocity going up is smaller. Here, there is no vertical component of velocity. Here, it's starting to go down. And here, it's going down even faster. But what do we notice? We notice that everywhere, this horizontal component of velocity, it's the same everywhere because there's no acceleration acting upon it. But when we're talking about the vertical component of velocity, well, there we do have the acceleration. We have the acceleration due to gravity. And, usually our projectile is flying up and velocity and the gravity is acting down. So we would call that a negative acceleration. And for the purposes of something like the MCAT, you can estimate gravity to be negative 10 meters per second squared. And again, it's not always going to be negative. That just depends on the problem, but oftentimes it will be because gravity tends to act against objects that are thrown into the air. Okay, so one last thing that is an implication of Vx being constant. Let's take a look at one of the kinematic equations, right? So we have a kinematic equation that says delta x is equal to v final delta t plus 1/2 a delta t squared. So we said that our acceleration is constant, or rather acceleration 0, I'm sorry. Our acceleration is 0, so that means that this whole term will just disappear. Thanks to that, we can say that our delta x in the horizontal direction, so this is all in the horizontal, is equal to our velocity in the horizontal direction, Vx, times the change in time. So if our object is initially launched so that it has a vertical velocity of, 10 meters per second and a horizontal velocity of 10 meters per second, and it's in the air for 5 seconds, we can say that the total distance that it traveled is just the horizontal, which is 10 meters per second, times the time. So it's going to travel 50 meters in that time frame. So I hope this video helped. If you have any questions, let me know. And as always, happy studying. If you found this video helpful, please take a second to hit the like button or comment down below. If anything in this video was unclear, or if you had a question about any other topic, please don't hesitate to comment it or send it to me in a message, and I'll do my best to answer it for you. Thanks for your support, and happy studying.